Hello，你好，同学们。OK，我是来自 SCS Education 的属性。So 呢，接下来的这些影片呢，我们会收录在这里，so 你们可以无限的观看。我们之前做的这个 SPM 考试攻略。OK，我们是来自 SCS Education 的升学辅导中心，都是提供一站式的免费升学服务。So 呢，如果是讲你之前还没有了解过我们的话，你可以通过 subscribe 我们的这个 YouTube、Facebook 跟 Instagram，就是 SCS Education 可以了解更多的。然后如果是说你对升学很迷茫，想要了解更多关于就是 SPM 啊、UEC、Diploma 或者 Degree、PhD 过后的这个升学管道怎么样的话呢？你可以PM 我们 ，OK，所以我们会安排就是辅导员跟你1对1的升学服务。OK，话不多说，OK，你们现在可以观看了。好，谢谢你们。
让我想一下。All right. Okay. So today we are going to discuss about the skill. How do we answer the physics paper? So same thing. I'm going to use a set of trial paper to discuss with you. All right. Okay. So, all right. Okay. Let's start with it. All right. So I hope that you already have the handout with you, so that it will be easier for you to see and to prepare what actually we are going to discuss. Okay. So, all right.
老师 ，sorry 啊，等一下，你的那个 screen 哦，你可以 share 出来吗 ？Maybe。on this share screen, yeah.
好，我试下啊。
可以吗
？share screen。
Yeah, OK. So 各位学生们看到哈？
好像看不到，看到吗？
现在看到吗？现在有看到你的 screen？ 哈，你click 去你要 share 的那个页面，然后就 share 就可以了。
等一等啊，等一下，让我处理另外一个方法，因为这个是用 Zoom 的方法，所以比较不一样。
可以。
想啊。
OK， 好了。So Mr. Ryan， 看这个 screen 可以了啊，各位学生看到哈？
看到吗？
看到吗？你们给一个1，好不好
？Okay. All right. Okay. So let's.
OK， 谢谢你们。
Okay. Great. All right. So let's start with the questions. Yeah. All right. So for the very first questions, when you look at this diagram, you will know that they are talking about your nuclear plant. So in nuclear plant, there is few things that must be in your mind. First thing you must know is either nuclear fusion or nuclear fissions. All right. So we have two types. Okay. All right. So after that, E equal to mc squared. So that is something very simple and basic in this part only, because in your nuclear physics, you will come up, continue with the quantum physics. So that's why in nuclear physics, they only study this few things for you. Okay. So, all right. Okay. Clear? All right. Okay. So let's continue with the first one. All right. Okay, so for nuclear plant, when we use the normal one, basically we are having fissions, right? Fissions. So fissions answer will be number 1. What's the difference between fission and fusion? Usually, sometimes students will have problem like they don't know fusions and fissions. Which one should be the correct one? Okay, very simple. All right, I will use the word U over here. You see, the only difference between these two words is the U and the I. So for U, U is referred to unite, right? So that's why unite means what? Two small atoms you combine together. That is fusion. Well, fissions will be you split them, right? You split them up. So split the I here. So that's why I will have nuclear fission means split. This is the nuclear plant. We are using nuclear fission. Okay, so for this formula, right, some students, they will still have problems on. They don't know what's the unit have to use for the E equal to mc squared. So remember, energy always we will use in joule, standard unit, while your mass will be standard unit kilogram, while the speed will be 3 times 10 power of 8 meter per second, right? Remember, must be in standard unit. So you don't need to worry about, should I use gram, this and that? Sorry, must be in kilogram. Okay, so first part, that is something very simple, right, about the nuclear. Okay, so, and we also have to prepare nuclear and the nuclear physics. This chapter is always very common in your exam. So you have to get ready for this chapter, right? All right, okay, let's go to number 2. All right, so based on diagram 1.1, state the two elements that will be used to control the rate of reactions. So when they say control the rate of the nuclear reactions, so we will have two. First one, control rod, and also moderator. Okay, all right, okay, very simple one. Okay, so nuclear energy becomes something turn to kinetic, kinetic become electric. So actually, this nuclear energy, they will turn into heat first. Okay, so you have to know the process, because usually in your physics, we will have two types of essay questions. One of the essay questions, they will ask you to explain the process for 4 marks. Okay, so let's go to this one first. Back to this first page. All right, okay, so the idea is, in nuclear reactor, here is where you will have the nuclear reactions. Nuclear reactions, they will release heat, because every time when your atom break or an atom combine, they will produce heat. The heat up the water turn the turbine produce electromagnetic induction here. So they produce electric. That's why you can produce electric to your substation and so on. So here, nuclear fissions or fusion produce the heat. The heat up the water. The water use the kinetic energy turn the turbine. Why? Because when you heat up the water, hot water, cold water, they will move. So when they move, they will turn the turbine. Turbine turn up in the dynamo, they produce induction. So that's why you will produce up your energy, right? Okay, so so I will just write out for all the process, right? Because in your essay, we will have 2 essay. One of the essay, usually it will be go to 1 mark definition, 4 marks explain what happened, and then 10 marks for your suggestions and modification, and then 5 more marks for calculation. So for this nuclear plant one, all right, so I will write out the way usually how I will suggest my students to do. Nuclear plant, first thing, we will talk about nuclear fusions or fissions, right? Let's say for this one, nuclear fission. Nuclear fission, then you will have heat energy release. Okay, heat energy release, the heat will turn the turbine. That's why here is where you have your kinetic energy. So from the kinetic energy, then you will have your electromagnetic induction. So here is what happened in the dynamo, right? Then they will produce electricity. So you see, we will have 4 marks. That's how we score the 4 marks. Okay. All right. So you can have an idea first. If you've got any questions, you can ask. Okay. Right? All good, yeah? Okay. So, all right. I will explain again because students ask again. Okay, so the idea is like that. Here is the nuclear fission. Nuclear fission, they break the atom from bigger to a smaller equal size atom, almost equal size atom. Then from here, you will produce heat. Every time, no matter fusions or fission, you will produce the heat. The heat heat up the water. The water will become hot. Hot water and cold water, they will have a motion, convection here. So when the water move in the high speed, they turn the turbine. Something turning inside your dynamo, you will produce induction. The induction produce electricity, the induced current. Okay, so 1, 2, 3, 4. That is the things that I just explained over here. Okay. All right, great. Okay. Yeah. All right. So, okay. All right. So now, oh, sorry, a bit more. Okay. So you can digest first. All right. Okay. The next questions, I think that most of the students, you all actually not really like them because it's about gravity. Okay. I need to let you know first, the history of the gravity is actually come from chapter in STPM, A level or matriculation one. So they add it a little bit for you. That's why they make your notes, make your part become a bit difficult. Okay, for the gravitations, because the formula lah. Okay, actually, when you come to gravity, make it simple. Gravity, the main formula is F equal to gmm over r squared. Okay, this force is your gravitational force. Gravitational force equal to gravitational constant. Okay, this constant is 6.67 times 10 power of -31, but you need to memorize. Exam will give you one. Okay, this 2m, how do we know what m is referred to? Both m actually is mass, right? It's mass. So the larger m is the heavier one because capital letter, so larger mass, larger mass, right? The small m, smaller mass. Then how about r? The r will be the distance from core to another core, right? Okay. So for example, you see the r. What they mention is the center of the earth, the center of the moon. This is meant by the r here. Must be core to core. Remember, if not, then you will calculate wrongly. Okay. So this is the first formula you have to know. Secondly, the second formula you have to know, which is, okay, this one, gravitational field strength, right? So which is equal to gm over r squared, right? Gm over r squared. Okay, so, all right, can I? Okay. Okay, next one. Another important formula you have to know about this gravity one is, okay, some students will ask me, teacher, G, is it same as acceleration? Yeah, yeah. The unit of G is meter per second square, right? Okay, so, okay. The third one, you must know there is another formula called centripetal force. Usually we use FC, centripetal force. Right, which is equal to mv squared over r. The mass of the object, the speed of the object moving, then the distance from the center of your circular motion. That is your centripetal force. Okay, so for this part, right, okay, your gravitational force, because this topic actually students very dislikes because the formula is very complicated. So when something is surrounding your earth, something surrounding satellite surrounding the earth, or the earth surrounding the sun, and so on, you will have this relation. Centripetal force equal to gravitational force. Okay, why I need this relation? Because this relation is going to help you to calculate how fast your object will be orbiting, moving in the orbit. So this one, Okay, mv squared over r equal to gmm over r squared. So that's why the m you simplify. At the end, you get the speed of orbiting actually is square root of gm over r, right? So this is the three few formula that we have to know about them. So usually exam very like to ask this part one, right? So I will just highlight for you this formula, okay, this relation, and then this one. Okay, so I let you have the idea first, then only we proceed. Right. So gravity, because last year they didn't ask really about gravity. They only asked about centripetal force, F equal to mv squared over r only. So that's why for this year, you have to put a little bit effort on this. Oh, who know that they will ask you? Okay. All right. Okay. So this formula will be very important for your chapter 3. Yeah? Actually, we still have one more is escape velocity. So, okay, I just proceed. Okay, for escape velocity, okay, later I will tell you about the importance of escape velocity. Yeah? Okay, escape velocity, sometimes they use a symbol VE for escape, right? So, gm over r square root. Okay, how do you differentiate these two things? The V is referred to your speed of orbiting, moving around the Earth. For example, the moon moving around the Earth, the speed, right? In the orbit. Okay, escape velocity will be referred to what is the speed for you to get away from your orbit. Maybe let's say the moon surrounding the Earth, orbiting the Earth. So if you more than that particular speed, right? More than escape velocity, then your moon will be get away from Earth. That is the formula. So how do you know about these two formula? Okay, very simple one. Escape velocity means you have to get out from the orbit. So you need very high speed. That's why I got the 2 here. Right? Got the 2 here. So this is the way how I get the formula differently. Okay? All right. Okay. Okay. So next one. Okay, get back to the questions. So diagram 2 show the object of S and M situated between the Earth is R, and then satellite from the moon will be small r. Okay, so if the mass of the Earth is ME, mass of moon is MM, and then your constant of gravitational is G. All right, so what by using the symbol, write the symbol for, okay, because they only ask you for expression, means you write the symbol only. You don't need to calculate anything. So gravitational attractions between the S and Earth. So S and Earth will be G mass of Earth multiplied mass of the satellite. Okay. All right. So I put ms as satellite, and then divided by capital R squared, because this is the distance between them, capital R squared. While between S and moon, this one. Okay, small r square. Okay. One more thing, right? Sure, student will ask teacher, why this one you will put mass of Earth as the capital mass one? Because compared to satellite, Earth is greater mass. While compared to moon, moon is larger mass compared to satellite. So that's why the symbol you must use correctly. So for these questions, right, students will lose mark due to this reason, because they did not put the symbol accurately. So they just put mm only, wrong. Put wrong symbol, lost mark. Put wrong R, also lost mark. So that's why careful with expression this word. You have to put correct symbol, because they give you the symbol everything already. So you cannot change them. Okay. All right. Okay. So this one will be the example for the first part, just how to write expression. So that's why next time when you come to expression this one, make sure the symbol you substitute in must be the symbol given in the questions, right? You don't run out from it. Okay, this one, right, we put M, just M only, no need to put MS. because the question got mentioned, mass of the satellite will be just m only. So that's why you don't put ms, just put m. All right. Now come to the questions second part. Okay, so gravitational questions, right, is always very test you in terms of what you know, in terms of arrangement of your algebraic, the alphabet, then only you can get calculations easily. So now they say, if the resultant force, okay, act on the S is 0. If you say act on point S is 0, means what? Just now, the attraction force formula that you have in your A1 and A2, the answer in A1, same as the answer in A2. That is what that means, right? Okay, so what is the distance of S from the moon? Okay, given that the R is 3.5 times 10 power of 8, and then mass of Earth is 81 times from the moon. Okay, so you don't bother so much of thing, you write the formula back first. This is a formula just now you have written. Okay, so you have to get the R. Okay, then this G you can simplify. And then don't forget, they already mentioned mass of Earth is 81 times from the moon. So change the Earth into moon. 81 times mass of moon. And then, sorry, one more thing, don't forget. The mass of the object S, you also can simplify. Okay, the R, 3.5 times 10 power of 8 squared, and then the small r, right? So from here, another thing you can simplify, the mass of the moon. So at the end, actually you get r squared equal to 3.5 times 10 power of 8 power 2 divided by 81. So here you have two choices you can do. First one, some students, they calculate this value first, 3.5 power of 8 power 2, then divided by 81. You get 1.51235 times 10 power of 15. Right? Sorry, 23 only. Right? 4 decimal point before that. So from here, only you square root this value. So you get 3.889 times 10 power of 7 meter. Okay? All right. Okay. So here, got one more important thing to tell you. Okay, from the calculator, you will get this value. Okay, you have to press your calculator because sometimes students very bad in using calculator. Okay, please don't write in standard form. Okay, this one also creates some issue, which is some teacher told you cannot use standard form. For some topic, you have to use standard form. Okay, actually, the standard one is 100,000 above have to use standard form. Right? Okay, less than 100,000, like example, 20,000, 30,000, 15,600, you don't use standard form, they will be fine. But 100,000 above, you have to use standard form. And usually, we will prefer you to put 3 decimal point only. 3 decimal point or 4 significant figures. Right? So this is the answer, the way how we do. So another student is, they will try to square root it. It means you square root both sides. 3.5 times 10 power of 8 power 2 divided by 81 square root. Then you can get the answer straight away. So you also will get the same answer. No problem. Don't forget unit. Unit lost, then everything lost. Okay. Right. So 3 marks, how we get final answer 1 mark. Substitute correct 1 mark. You write. Okay. You write equal to 1 mark. So that's the way how you get the 3 marks there. Okay. All right. Some students will say, if you square root, why you use negative value? Radius or distance is considered as scalar quantity. They don't have negative value. That's why you can just write positive value will do. Okay. All right. So this is the way how you solve the 3 marks question for this one. So remember, very pantang, we all write in full numbers like this. This one already more than 100,000. 100,000 means what? Here, less than 6 digit, we can write the whole number. But 6 digit above, we have to write standard form. Okay? All right. So this is the answer. Okay. All right. Okay. All right. So this is the idea of your chapter guarantee. Okay. All right. So when you do any calculation, make sure the number of significant figures must be very precise. If not, then you will lose mark over there. Okay. All right. Okay. Try to press the calculator because sometimes your problem is press calculator also press wrong. That's why you will get wrong answer. Okay. Okay, after this, we will go to number 3. Number 3 is also a Form 5 topic. It's about the diode. Okay. All right. Okay. So same thing for paper 2 physics. You will have 60 marks for the structure question. Then for part B, we will have 2 essay to choose one, and then part C will be only 1 essay and you cannot choose. Same idea, right? And then paper 3 will be Amali, same like your physics and chemistry. Physics, chemistry, biology as well. Okay, okay, the third questions. All right, diagram 3.1 show the 2 circuit, right? So when you see there is a diode, right, and then the reading, this is the thing. You have to know the difference among them. Okay, so all right, you see, when you put diode 0, this one we call them as reverse bias. It means current cannot flow. Reverse bias stands for current cannot flow. Okay, then this one you put correctly, then the value of the ammeter exists. So this one will be referred to forward bias. Okay. Okay. Right. Okay. All right. So okay, you see, if let's say they don't give you the ammeter, then how we know there is a forward or backward bias? Okay, simple. You look at the battery. Battery, positive, negative, positive, negative. Okay, so first thing, positive, the current flow, 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 flow. But you see, when flow until here, did you see this one? This one stands for block. Current cannot continue. That's why reverse bias. Current cannot continue. That's why your ammeter 0 cannot complete. But when you have this one, you see current flow, current flow, current flow, current flow. Wait, current is not blocked. It's not blocked means they continue go forward. So this one complete circuit. That's why current exists. So this is the diode, right? How they actually help you to allow current flow in one direction. Okay. All right. So here have a student ask, teacher, how do we know what happened inside the diode? How do we know they are forward bias or backward bias? Okay. All right. Very simple one. Your diode, you have to know what is their connection. Actually, your diode with this symbol, this is an anode. The larger size one is anode. Okay, here is anode. Then here is cathode. Okay, The anode is referred to positive, cathode is referred to negative. So the positive must be with the positive of the battery. Then only they can have forward bias. If here positive and then your cathode here negative, then you will get reverse bias. So this is the way how we know whether they got forward or backward bias if you don't want to use the current one. So we have two different ways to determine they are forward or backward bias, right? So it all depends on your decisions. So for me, I prefer, okay, if positive, you write the positive, negative of the battery, current flow. Okay, here no block, that's why current complete circuit. Here, current flow, here block, current cannot continue, that's why reverse bias. And past year question also asked before the mechanism, how diode actually function. Okay, this one, got student asked, teacher can explain the mechanism, no problem. Okay, so if let's say you want to explain anything about your diode, okay, now you have to know diode is come from P and N, P and N, right? P type semiconductor, N type semiconductor. Okay, so I say about forward bias first. Okay, for forward bias, okay, you see, P is referred to you have a lot of hole. Hole, they are positive. While N type is referred to you have a lot of electrons, they are negative charge. Okay, when current come in, current is positive. So what happened? When current come in this way, positive, positive. Okay, first one you show. Okay, positive, positive. Current will be repelled because repel the hole because positive same charge. So all the hole repel. When they repel, actually they are pushing the hole to one side. Okay, so for example, when the current come in, okay, so all the hole will be pushed to one side. So you see, when current come in, all the hole push to one side. So hole is positive, electron is negative. So they will attract the electron to jump over. So when the electron jump over, circuit complete. That's why current flow, that is forward bias. Okay, so this is the mechanism how the diode actually function. Okay, all right. So let me explain again. Okay, so this further called junction gap. Okay, junction gap is neutral, no charge one. So that's why when you have anything come in, they will become the gap. Electron cannot pass, current cannot pass like that. So I talk about forward bias. When current come in, okay, current is positive and repel hole. Okay, so all holes in P-type semiconductor will be pushed to the junction gap. Okay, so when junction gap being pushed over here already, so the junction gap will be more narrow. So current will be able to pass through. So this is the way how do we explain the diode. So first one, you talk about current come in positive, they repel the hole. So the junction gap becomes smaller. Junction gap smaller, then electron can pass through. That's why the junction gap become narrow. Electric current can flow through. That's why you have forward bias. So that's why, for me, if possible, to ask diode mechanism. To some students that dislike electronic, then you have problems. So if because the student asked, so I explain to you the 4 marks how we get. Okay, all right. Okay. Okay. So, all right. Okay. Get back to the questions. State one type of semiconductor. So the most common semiconductor we can have is, you can have few of them, silicon or germanium, right? So these two is the most basic semiconductor that we have, right? Silicon or germanium. For some students will ask teacher, can I use symbol? For physics better, you don't use symbol. We assume the marker do know silicon is Si, so you write the full name is better, much more safe, right? Okay. Give two reasons that cause the difference between reading of the ammeter in the circuit P and Q. Okay. So why they have different? Why they have reading 0 and 3? Okay. So first thing, okay, electric current flow in Q, but not flow in P, right? Because they ask about why they have different ammeter, so you have to tell this one no current flow, this one got current flow, right? Okay. So one more thing, because right here they got mentioned difference between, so it will be more look like you have to compare both. That's the reason you have to write related current flow in Q but not in P. You have to mention both. Okay. All right. Then after that, wait, here I make correction first. No current flow in P. Mention no current flow. Don't just say not flow in P. Not so correct. So you mention current on both sides. Okay. All right. Okay. Why? Because, okay, first reason you say no current. Then second part, why no current? So you mention, okay, all right, circuit P is experience reverse bias, but circuit Q is experience forward bias. So that's why you have to compare both. If not, you lost mark. Some students will say that, teacher, if I don't want to say forward bias, reverse bias, can or not? Can. You can write circuit P is connected. Okay. In circuit P, the diode cathode is connected to the positive terminal of the battery. But then the diode in circuit Q with the cathode connected to the positive terminal of the battery. You have to mention terminal, so very long. That's why I prefer I prefer forward bias, reverse bias. It will be better. Yeah, you can write in point form, no problem. Right? So far in chemistry and physics, we are allowed the student to write point form. But other subject, I cannot tell you. Especially what I heard from the student is bio and sejarah not allowed. But for chemistry, physics, yes, you can write in point form. But the point form cannot be 2-point form. For example, current. Okay, I give you some example. This is a very good answer. So some student, okay, write like this. Current in P, no. Current in Q, yes. P backward bias, Q forward bias. Okay. Right. If you write like this, I'm sorry, I will give you 0. Don't write too simple. Write complete sentence to be okay one. But if let's say you say that, teacher, my English not good, then if I cannot write, I write wrong in grammar, don't worry. We will mark you grammar, and some more I have to let you know that not all chemistry physics teacher good in grammar or English one. Right? So don't worry about the grammar part. So don't worry about it. This one we banned, but this one is still okay. Okay. So based on the answer in 3B, what is the function of the diode in the circuit? Okay. So if they ask for function, diode only have one function. Okay, you can say act as rectifier. Okay, or you can say only allow electric current flow in one direction. That is the way how you answer the function there. Okay, all right. Okay, so you can jot down. We go through one more part, then only we take a short break of 15 minutes, because let you have a fresh mind to continue the next part. In this chapter, electronic, the first part you learn about thermonic emission. There's a calculation there. Then after that, you come to this part. Diode. Then next part will be transistor. Transistor will be challenging, right? But the pattern to answer the question is fixed, so you can go through that. If you've got any question, you can ask also. Okay. All right. Okay. Next question. Okay. Diagram 3.2 show the output, okay, of the CRO show on the screen. So you see, this one is a full wave because all the wave being flow, right? And some more they got 4 diode. Got 4 diode and the wave is like this. This one is confirmed is a full wave rectification, right? So you can write down full wave rectification. Okay. All right. Okay. So what's the difference between full wave and half wave? If this is full wave, half wave will be got, then this one no more, then got, then no more. So they will be alternate 1, 3, and 5 like that. So some of the wave will be not able to pass through. That is half wave. So they ask you, explain why output signal is produced such way. Okay, 2 marks. How do we score them? All right. Okay, you have to tell why you get full wave. So the first one you mentioned, the circuit, okay, is connected with 4 diodes, okay, to have full wave rectification. This one, okay, then okay, so alternate current or able to pass through the diodes and complete circuit. Because actually your AC, they can be flow in 2 ways. So AC, either you can flow in clockwise or anti-clockwise. So because both ways also can allow the current flow, that's why you will have full wave rectifications. Okay. Or maybe some students, if you know that AC is got AC have a cycle. So as you know that AC you have like this. This is first cycle, this is second half cycle. So you can say the second half cycle, all right, also able to complete the circuit. Also same as the answer here. So you can have 2 answers to explain. So you can write in other way, the second half cycle is able to complete the circuit as well. Right? So that will be the other way of how you explain. So when they give you 2 marks means 2 things. So how you score the 2 marks? Usually you can see from the diagram they got 1 mark, and then the diagram, the structure, the arrangement give you the second marks, right? So that is the way how we get that. Okay. Okay, no problem. I show you. Okay, you see, okay. So why the second half cycle also complete the circuit? Okay, I show you in the diagram. Okay, all right. Okay, I use two color, then it will be easier for you. All right, first one. Okay. So let's say this is the cycle that flow. All right. Okay, so cycle flow in clockwise. Okay, so until this part, current will not flow down because here is reverse bias. So you continue go up. Okay, here also reverse bias you cannot go. So you go forward and come to the CRO, and then you complete the circuit. Okay, until here, you will choose to go up. Why? Because you want to complete the circuit. So you see, the blue cycle complete the circuit already, right? Okay. Okay, so I erase it. I do a second cycle. Okay, so this one is the blue one. So blue cycle complete circuit. Okay, all right. Please draw the arrow. Then only you will know how the current flow. Okay, then now you see on the second cycle, because your AC is always two cycle, upper cycle, lower cycle. The lower cycle in other way, in anti-clockwise. So flow here, all right. Until this part, here reverse bias cannot, you go up. Here also reverse bias, no choice, you go forward here. And they'll come down. Okay. So until this part, they will not come back to the original way. They will go up and then complete. So you see, red or blue also able to complete, come back to the origin, come back to your source, to the electric power. So that's why circuit is complete. And number two, did you see that no matter blue color or red color, both current flow in the same direction? That's why it is a full wave rectification. So this is the things that actually you are asking me, why they will complete the circuit and flow in one way. So this is your full wave rectification idea. Okay, all right now. Okay, okay. So now, if you have questions, still have questions, you can send in the group chat, and then we will take a short break of 15 minutes. Okay, I pass back to the MC. Then later, 15 minutes later, we will continue again. So wish that you have a good refresh mind already, and then let's go through with the second questions here. Okay. All right. Okay. So the next questions we are trying to go through one is about the electricity. So how do we know this is about electricity? Okay. So first thing, you go through the question, they got mentioned electric circuit, you got battery, and then actually when you come to electric chapter, right, electricity chapter, the first thing you have to know whether this question is asking about internal resistance or not internal resistance first. So this one, okay, we go through them. Yeah, here is the keyword, electromotive force. If you have electromotive force, confirm you will have internal resistance questions, right? So this is EMF. Okay, this is internal resistance, the small r. Okay, so for your internal resistance or the electromotive force questions, we will have few formula that you have to know. First one, EMF is equal to drop voltage plus terminal voltage. Okay, what is VT and VD? Okay, like this. This is the battery. The battery one will have the drop voltage within the battery. This is drop voltage. While the outside one, other than the battery, outside the battery, this one is your drop voltage. Okay, so EMF actually is referred to your total voltage outside one plus inside one. Or maybe sometimes the formula that can change into IR plus IR. The current, they are the same current, right? Whatever current flow is the same, but the capital R is the resistance. This one, this is the R. Okay, and then the small r is the internal resistance inside the battery one. So that's why you can factorize them, become this formula. Okay, or maybe sometime they will prefer you to use this formula. EMF equal to terminal voltage plus current multiplied internal resistance. So this is also another form of the formula that actually come from the origin. They just make some arrangement become this only. Okay, so now this formula, right? Actually, the third one, we can do some arrangement become suitable for us to use for the graph. Okay, so like this, here, when we try to rearrange them, we put the V as the title. VT equal to E minus IR. Okay, you rearrange VT equal to negative IR plus E, like this. So this is your y-axis. This is your, okay. This one, I rearrange a bit. I put the negative R in front, I behind. Negative R is the gradient, the current is the X. This one is the intercept point. So you see, from here, you can get the relation between the graph with this. This is your VT, your y-axis, right? Your current, your x-axis. So the gradient of the graph is negative R. You can get your internal resistance. How you get your EMF? EMF simple. You just extend the line, this one. Extend the line until they touch the point here. This is EMF. Okay? All right. Okay. Now, okay. So the question now they ask you, all right, what is the meaning of EMF? So the work done by a charge, all right, work done by a column of charge. You have to mention a column of charge transfer in a complete circuit. So this is the way how you explain EMF. So you must have the keywords complete, work done, a column of charge, then only you get full marks. Or what is VD? VD is drop voltage that inside your battery one. VT is terminal voltage. Terminal voltage means outside, right? VD drop voltage. VT terminal voltage outside one. So this is the definition. The work done by a column of charge to move in a complete circuit. Okay, all right, great. Okay, so where should we put our wattmeter? Okay, here we got something. Okay, all right. If you want to measure your EMF, okay, but this question actually not so correct, not so accurate, because they did not mention where is the position suitable for the wattmeter. Okay, so what you want to measure first? If you want to measure the EMF, okay, you have to put an X, right? Or else, if you want to measure the voltage of the resistor, you have to put at the Y. So this question not very precise. Okay, that's why I will assume that actually this question is asking for EMF. So EMF have to put an X. And one more thing, wattmeter always must be parallel one. Parallel with anything. Parallel with the battery, parallel with the resistor, they're always parallel, right? If you want to get the current have to be series. Okay, all right, yeah, okay, next page. All right, okay, so based on the EMF shown on the graph, determine your EMF I show already. 2 marks. How you get the 2 marks? The first mark is go back to your questions, the graph. I extend the line. Here 1 mark. The value 11 watt. 11 watt. Okay. All right. So these questions, right? You just write 11 watt because they use 11. So no need to write anything. 11. Okay. How you get internal resistance? All right. Because just now I already told you the gradient is your internal resistance. So what you have to do is, okay, you get your gradient first. Okay, how you get the best gradient? Okay, I tell you first, don't go and pick those very difficult find point. You just find this one. This is the first point, 0, 11. The second point, 8, 3. Right now, 8, 3. So this is the gradient. Okay. One more thing I have to advise you, when you want to calculate gradient, I will prefer you all get the coordinate, write the coordinate correctly, and then form a right angle triangle by writing the right angle here. Do like this better, right? Do like this better. Okay. Then only you calculate the value. Like this, you get 1 mark. Okay, right? Okay, so from the gradient, here we calculate the gradient. So the gradient is 11 minus 3, and then the coordinate of x 0 minus 8. You get -1, don't worry, correct. Because gradient equal to negative R, right? Negative internal resistance. That's why gradient equal to 1.0 ampere. Okay, right. So this is the part where the student will lose mark. Actually, for me, this question shouldn't be giving 2 marks, one should be 3 marks because the triangle, the triangle you draw 1 mark, then calculate gradient 1 mark, final answer 1 mark. Supposed to be 3 marks like this. So since that they are the one that set the questions, so I cannot question anything. So if like that, then triangle 1 mark, here 1 mark. Okay, so this is 3 things I will usually do. When you calculate gradient, must have the triangle with the coordinate. You draw the right angle, calculate the gradient, show the step, and then the final answer with unit. Like this, that is the safest one. Okay, now these questions, they ask you, state which circuit is brighter, explain your answer. So 3 marks, 3 marks go for 1 mark, which one brighter, 2 marks go for explain your answer. So actually, when you compare, actually your circuit B is brighter. So first point, we write circuit B have light brighter bulb than circuit A. So what's the reason? Why circuit B is brighter than circuit A? So first thing, because they put in parallel. So when you put in parallel, one of the things you must remember, parallel circuit, always their effective resistance smaller one. If you have series circuit, usually your resistance will be greater. So that's why for this one, you will write, okay, because the dry cells in B arranged in parallel. Okay, but dry cell arranged in series 4A. Okay, so smaller effective resistance give you greater current. Higher effective resistance, that's why give you smaller gradient, smaller current flow. So the third marks will be, okay, the electric current flow in B is greater than A. That's the reason. Okay, so I just repeat again. Parallel cell will give you smaller effective resistance. So smaller effective resistance give you greater current. So greater current flow, then your bulb will be brighter. Why? Because your bulb need larger current flow only can heat the filament. More current, more heating, produce more light. That's the reason. So bulb, you need higher current, only they can produce greater, brighter bulbs. So this is the part for your internal resistance one. So that's why for your physics, all the explanation, first thing you have to know how many marks allocate for them. 3 marks, 1 for the choice, 2 more marks for your reason. Then the reason must be related with the diagram. So first thing, parallel series, you score second mark. Further up, parallel series, so what? Current flow differently. That's the thing. That's the reason. Okay. Okay. All right. Okay. So we will have the next one will be the question about heat and pressure. Okay. All right. Okay. All right. Okay. This one. All right. Diagram 5.1, 5.2 show the gas at the constant mass is heat with a piston. Okay. So okay. So first thing, you can see that here less heat, here more heat. All right. So of course, more heat, the gas will expand. That's why the volume increase. Okay. All right. Okay. So now, heat is what form of energy? Okay. When you say degree of hotness, this is temperature. Okay. All right. Okay. Next one. All right. Compare 5.1, 5.2. The heat given, as I told you, 1 fire, 3 fire. So 5.1 less than 5.2. Or you write 5.2 greater than 5.1 also can. Right? But one important thing is, can you write in symbol? Ole, no problem, allowed. But if you worry, then you use a full sentence of diagram 5.1 provide less heat than 5.2. Can, but very long. The temperature, of course, more heat, more temperature. 5.1 less than 5.2. Very straightforward on this question. Not difficult. You can write symbol. But if you, let's say you worry about writing symbol, you can just write 5.1 is less than 5.2 equal. No problem, be allowed, right? You lost mark 1. Okay. So the volume, also same thing. Higher the temperature, larger the volume. So 5.1 less than 5.2. Okay. All right. Compare to your based on the diagram in 5B, state the relation between heat and temperature. Okay. So now what they want you to compare. This one also a bit trouble one. Temperature and heat. They mention temperature first. So you must say temperature increase as heat supply increase. Some student will say, teacher, this one, can I terbalik? I write the heat in front, temperature behind? Don't, because they already mentioned temperature in front, then only heat. That's why temperature must in front, heat behind. So you don't change their arrangement, right? So same thing, temperature and volume. So okay, for this one, right? I give you two answers. You see which one correct. Temperature increase, volume increase, or the temperature is directly proportional to volume. Okay, so which one will be the correct one? Because now you are talking about temperature and volume. So if you still remember, temperature and volume is Charles' law. So temperature, volume is a Charles' law. That's why you have to use directly proportional. This one you don't use. Those who have law, those who have principle, you can use directly. You have to use directly inversely proportional one. You cannot use number one, right? Because they have Charles' law. Have guess law must use directly inversely proportional. That is the point where that usually student lost point because of that. So that's why make sure you remember. Right? Like number one, why cannot? Do they have any law talk about temperature and heat? You go through them, there's no. That's why you cannot use directly inversely. Only number two can. Right? This is the thing that I have to remind you. Okay. Right? Make it easy. Got law, got principle one, you must use directly inversely proportional, this kind of keywords. Okay. All right. Okay. Right. Next one. Okay. Okay. So calculations. All right. Okay. A with temperature 27 degree. This is the 0.24 meter cube. Okay. Then you have a volume. What's the volume for 80 degrees Celsius? Okay. This is a Charles law. So we will use V1 T1 equal to V2 T2. All right. Okay. All right. Okay. So, all right. Okay. V1 is the volume. Okay. It's the red color, yellow color one. So actually, you put V1 or V2 depends on you, no problem. What I mean is yellow color one you put at V2 T2 also can, but they must be continue the same pair. So 0.24, no problem. You put meter cube can. Okay. Temperature, remember in gas law, you must use in Kelvin. That's why you must add 273. While this one, the volume, I don't know, 80 degree plus 273. Must add, must change to Kelvin. You cannot use degrees Celsius. You must change to Kelvin. How you change? Just add 273 only. Okay, so your volume will be 0.2824 meter cube. Why meter cube? Because follow here meter cube, here meter cube also. Right? So remember, gas law have to use temperature in Kelvin unit. Cannot use degrees Celsius. If not, sure a lot of problems and wrong one. Okay? right? And then, as I said before, four significant figures or 3 decimal point. So I put 4 figures lah, because when you press calculator, the value is quite nice, right? So you can just use them. If 2 wrong one, you can pick 2 significant figures. 3 decimal point. Okay, all right. Okay. Okay, so the last questions. Okay, we can discuss one more last questions. Then we open for Q&A. Then we will complete for the first day seminar. Okay. All right. Great. Okay. Like come to this one. Okay. So diagram 6.1, 6.2 show the 2 different method to push the machine. Okay. This one is a push. This one is a pull. So if push and pull, the force they act differently. This one you push down. If you push down, the force that you can resolve will be go forward, that is your Fx, go down will be Fy, right? Because you want to have resultant force in the middle. So when you resolve, it must be one up, one down. This one you pull up. That's why you will have your Fx horizontal go right and then Fy go up, right? Because the F must be in the between of them. So that's why horizontal go right, right? Vertical one go up to get the resultant force over here. Okay, so this is the way how I see the questions pull and push, how they're different. Okay, all right. Okay, some students say, teacher, if I use other direction, I can show you. So let's say if your direction force is like this way, you push in this way. So where is your Fx, Fy? You resolve them. Fx is here, Fy go down. So they must be in the between. The F must be in the between. Okay, all right. Okay. Okay. So now here 20 degree. So this 20 degree, actually, if you really resolve them already, the 20 degree actually is here, right? Because why? When you resolve them, these two, they are parallel. That's why your zigzag angle here 20. So this one, if here 20, this one 20 degree, no problem. Okay. So the first question they ask you, what do you mean by resolution of force? Resolving the force into X and Y component. If you don't want to use X and Y, no problem. You can use horizontal and vertical component. Either one way. Both also correct one, don't worry. Right? Okay, all right. So now the question I will ask you. Okay, draw the diagram to show the resolution of force. Okay, now you see this one. How do we make them become a triangle? Okay, so let's say, all right, I remain the Fy go down, and I remain the force. This one go here. So you have to move one of them. Okay, so this one I remain, this one I remain. So Fx is the one that I have to move. So this force, right, even though I know it's on the top here, but actually in this resolution of force, this force, as long as same direction, you can just move down, become your Fx. And here is your right angle. So same thing. This one, let's say, okay, I fixed my Fx and F already. Then my Fy, I have to move. So Fy from here, as long as same direction, then you can get the triangle. So you have to fix two of them. then the other one you move. Okay, maybe some students say, teacher, you fix Fy and Fma. How about if you fix Fx? Can I fix the Fx, and then here is the force. All right. Okay, so where your Fy is supposed to be here. Then you just move to the right side. Okay, this is Fy. Right, same, exactly the same one. Calculation, everything also the same one. Just you draw in different orientation only. Okay, so that's why I cannot say you're wrong. I cannot say the diagram, how was it, and so on. I just can tell you they are different method to get the triangle, but they are still all same. Okay, so later when you draw the triangle, you can choose either one you want. So my method is I fix one of them. Sorry, I fix two of them. Then the other one I move. So as long as same direction, the force value is still the same one. Right? So this is the answer for your part B. Okay. All right. Okay. So next one, they ask you to compare them because they got say the word compare. So when you compare, you must use the connection word. So for example, I know 6.1 is push, while 6.2 is pull. So this word is a compare word. So no problem. If you don't want to use while, you can say but. No problem. Okay. 6.1 upward, 6.2 downward. Then use a connection word. But while also can. Like this, you will score, right? But if you say 6.1 upward, comma 6.2 downward, wrong. Because they got already mentioned compare. Compare means you have to say this, then, and so on, right? Okay. Right. So then why 6.1? The force acting to the ground greater, because okay, like this. Your machine, sure the weight is go down one. So if you check 6.1, sorry, I balik already. 6.1 is downward, 6.2 is upward. Sorry. Okay. All right. So 6.1 downward plus weight also go down. That's why 6.1 is add up Fy plus weight. But 6.2 upward, weight minus Fy, because they go direction. Okay, they go different direction, so you minus, right? Weight go down, Fy go up, that's why you minus. All right. Okay. No problem. You use but or while can, no problem. Both also can, but you must use the connection word. Okay, when you have the word of compare, right? No issue. Okay, all right. Then the next question, they say, relate the directions between the force of vertical with the net force. So they say vertical force first, then only the net force. That's what you have to mention. Okay, either one. Upward force will reduce the downward, the net force act on the ground, because the vertical component first. So you must put this upward, downward in front. then only you can say net force behind. So what I mean is you don't change their arrangement. Vertical first, then only net. Vertical first, only net. You don't change their arrangement. So if you say that the net force depends on the direction of the force, you say net force first, high possibility you were wrong, right? So if you change to downward, then this one will be increase, right? So depends on which one you use. We have two answers there. Okay, so actually which one is better? So actually we prefer push method. Okay, 2 marks, 1 mark for choose push method. Why? Push method produce more net force acting to the ground. So the blade will be easier to cut the grass. Okay, so this is the answer. Okay, but actually 2 marks, you just mentioned push better and then push increase more force act on ground. I just explained one more point because I worry that push nearer to ground. So what's the problem? Nearer to ground, that's why the blade will be easier to cut the grass. That's the idea of it. Okay, all right. Okay, so that will be all for the 5C2. Okay, here got a question. Student asked why you cannot write temperature and volume increase just now the Charles law one, because the question 5C2 is involved Charles law. Got law, got principle, you must use directly inversely proportional. You cannot use increase decrease like that. Got principle one, got law one, you must use directly inversely either one, right? So like the volume and temperature is related by Charles law. That's why we will use directly proportional. Okay, so this is the answer. This is the reason.
感谢同学们的观看，记得不要忘了 subscribe、like、share and comment。我们下次再见哦。